Hi all, this is the badging video for the casting machine here at MakeHaven. This machine, which is called a Kayak investment vacuum casting machine, is a crucial part of the workflow of casting. But before I explain exactly what this machine does, I want to explain the steps of casting so that you understand where this fits into it. So the first step is that you need some kind of shape, and that is the shape of the final thing that it is that you want to make. That's called a positive in this case. So what I did is I went on the computer and I designed and 3D printed this little shape. So this is just a robot, and on the back of it I put what's called a sprue. And so this is the space that metal is going to flow into before going into our little robot. This shape, this 3D printed piece of plastic, and this was printed in PLA on a normal 3D printer, gets put into here. So this is just a cap. And then we take this piece and put it in this flask. So this flask goes just like this. So now our little robot is up inside of here. And once it's in here, then we take some tape and wrap the tape around these holes. So then these holes are all closed up, and we pour a special kind of plaster into here. So then it's all encased in plaster, and I'll show you that process. As a note, while I 3D printed this piece, because that was what was easiest for me to do, there are a lot of ways to make that positive piece that is eventually going to be what is made out of metal. So for example, a traditional way in jewelry making is to make it out of wax. So you can make rings, for example, you carve them out of wax, attach a sprue just like we did, and then put it into the mold. You can use different kinds of 3D printers. The idea is it needs to be some kind of material that will melt out when you're done. So both wax, and in this case PLA, will melt and burn out of that plaster. So we pour plaster around it, we let it cure, and then we can, once that's done, this is full of plaster, we can take the tape off of the sides to expose those holes, take this off of the bottom, and this little guy will now be fully trapped in the plaster down in there. So it'll still be in here just like this. And then we're going to take this and put it in the kiln in the welding area like this. And so whether it is wax or plastic or whatever, at a high enough temperature, it'll all burn out of this hole in the bottom. So all of this material will burn and smoke right out of the bottom. And what we'll be left with is a plaster mold. And another note is the plaster is often called investment. It's an investment because it is going to actually disappear in the end, but it's useful for getting our final product. But after we burn out the wax or the plastic, we're left with that investment with a cavity inside in the negative of this shape. And so now what we can do is we're going to take it out of the kiln, and while it's scorching hot, we're going to put it right into here. And so this pulls a vacuum. And so we're going to set this to the casting chamber setting. It's going to pull air down through the little void that we made and through the plaster. And then we take molten metal, and we can melt it a bunch of different ways, and we'll cover that. You pour it into that cavity, and it gets sucked down into that cavity, into that mold. The reason why you want this to be very hot is because you want that metal to stay liquid for as long as possible. And if it's cold, then as soon as you put that molten metal in there, it'll suck the heat out of it and cool it more quickly. And you want it to stay liquid for as long as possible to get into all the nooks and crannies. So then you're going to use the tongs, because it is quite hot, and you're going to take this out and dunk it in water, and all that plaster, the investment, is just going to dissolve away, and you'll be left with this cavity but full of metal. So whether that's a ring or a little robot or whatever it is you want, if you've done everything well, you should be left with your piece. So there are a lot of steps within that we'll go into more depth around. For example, this side of the table is used for pulling air out of your investment to make sure that it makes a really good cast, to make sure that the plaster doesn't have any bubbles in it, and that it goes right around all the little nooks and crannies on your piece. And then we'll obviously cover the steps around melting metal and making the plaster and all of that. So the first step of this process is making the positive shape that you want to mimic in metal. So here I've made it in a program called Fusion 360, and I took the MakeHaven robot logo and turned it into a three-dimensional shape, and then added this thing called a sprue. So the purpose of the sprue is to take the metal from where we pour it in and guide it down into your shape. So let's say you had some really big shape, say a circle. If you put all of the metal into one side of the circle, it might not make it all the way around. So sometimes you want a sprue with multiple legs going out to your shape. Now, personally, I feel more comfortable designing things on the computer than carving it out of hand, because I'm not a talented wax carver. But either way, whether you design it in a computer and put it on a 3D printer, or you carve it out by hand out of wax, the idea is the same, that you need to have a space for the metal to come in and evenly disperse around your part. Because the system is using a vacuum to suck the metal in and pulling air through the plaster, you don't need to worry about having anywhere for the air to go like you do in some other kinds of casting. Also, as a note, this plug is a specific size. So it's important to know this size because that plugs into the piece of rubber in the base. So the two important features for the sprue, this piece that fits right in here, is that the diameter of this piece, of this circle, is 0.41 inches, because that's about what the size of this is. And then the length is about 1/4 of an inch, 0.25 inches. Then I could have just continued that cylindrical shape down into the chest of the robot, but that would leave a pretty big circle in the chest that I would then need to cut off, because this will all be metal, and then polish. So I just made it a little narrower to make the cleanup work that I need to do on the robot a little less. If you're doing this out of wax, it's the same idea. You just need to make a shape that'll fit into that hole so that when you do the casting, the metal can flow right into your piece. Something that is pretty cool about this process is that the plaster and then the metal will capture really fine details. So here on this 3D print, you might be able to see that there's little imperfections in here. You can see the lines from the 3D printer. There's a little hair in the neck, and the final metal piece will capture that. So if you wanted to do something that looked really nice and required the least amount of work afterwards, you want to make this look really nice. So you would polish this, maybe smooth it and coat it to make it as nice as possible. But you're either going to do the work here or you're going to do the work on the metal at the end. So whichever way is easier for you. But just bear that in mind, that the plaster and then the metal will capture quite small details, especially if you get the temperature of the metal right, so it can flow into all the little nooks and crannies. Something else to bear in mind is that you want the path for the metal to be as short as possible. So if you have things that are farther away, or doing a whole, you could do a whole tree of parts. So if you wanted to do something like 10 rings, then you'd do something like this, where you have the metal come in down that central sprue and then run off to each of your rings all around the edges. So this was the original in wax that they made, and then this is the final one out of what looks like gold. All right, so that's the first step, is making the piece out of some material. So here we have ours. The next step is going to be casting it in plaster. So I will show you that step now. So most of the tools needed for the casting process are in this set of drawers. Down in this bottom drawer, we have a whole bunch of things. So they're listed on the front, but we'll look at them on the inside. So we have our flasks. Here's a larger size flask if you want to do a bigger thing. These are more adapter plates, as well as the silicone gaskets. This is a whisk that we use for mixing up the plaster. This is a stand that we use underneath the flask when we're burning out the plastic or the wax. These are 2 measuring cups that we're going to use shortly for the plaster and water. There's a scale, and then there's borax for the melting of the metal. So for now, we're going to grab the measuring cups, the scale, and the whisk. So here we're looking at the data sheet for the plaster that we use. There are a bunch of plasters available, but this is the one that we have in the store here at MakeHaven. And this document is linked on the tool page. It has a bunch of important information on it, including the mix ratios, the working times, about 10 minutes. And here specifically, we're going to be looking at the mixing numbers. So it's saying that you need to measure the size of the flask to know the volume. And then for every cubic inch, you multiply it by one of these numbers to see how much investment you need, the plaster, and how much water is needed. So I already did that math for you. You need about 621 grams of plaster and 243 grams of water. So there are a few different ratios here. In general, I start with a 39 because that's what it says here. However, I have found that sometimes it needs a little more water to get to the right consistency. So normally I mix it and then just add a little bit if it needs to get to the right sort of pancake batter consistency. On the second page of the data sheet, there's also a bunch of information on casting and vacuuming and heating. So feel free to review this if you aren't getting good results and want to see the exact specifications of the manufacturer. The next step is to wrap this up in tape. It doesn't really matter what kind of tape. We're going to remove it before it goes in the kiln. So I just grabbed this red duct tape. And the goal is just to make sure that all the holes are covered so that the plaster can't escape. So now I'm going to measure out the appropriate amounts of the water and the plaster. And we're going to start by tairing the weight of the measuring cup, which just means to tell the scale to reset this is at 0 point. It's important to keep this bag sealed when you're not using it so that moisture from the air can't get in and ruin it, because then it will expire much faster. And now I'm just going to seal the bag back up. And now when we put this measuring cup on, it should read 0 because the two measuring cups are about the same weight. When you're making the plaster mixture, the goal is for it to be totally smooth and clump free because you want it to be able to go around all the little details and contours of your design. So there are a few ways to do that. One is you always add the plaster to the water. If you add the water to the plaster, it just makes a clumpy mess. So you slowly sprinkle the plaster into the water while mixing it with the whisk, and in that way you can get a nice smooth consistency. And then our clock is ticking, that 10-minute clock, until that plaster needs to be poured at the very latest. So what we're going to do is we're going to do this over by the casting machine, because as soon as it's mixed, we're going to put this container, which will have the plaster, into the investment casting table to pull any bubbles out that were added when we mixed it up with the whisk. Then we're going to take that plaster mixture and pour it into our flask here. And we're going to do the same thing. We're going to put the flask back into that investment casting table and pull any bubbles out that may have gotten trapped around our part. Then we can just let it sit to cure. And it takes, it says, between 2 and 6 hours for the plaster to cure. So, maybe give it 4 hours to be comfortable that that plaster is cured enough, because then you're going to put it in the kiln, and if it has too much water in it, the whole thing will just blow up, because all that water is just boiling. So that's why it's important to make sure that you let it dry as long as possible. So here we have the flask, which we have the tape around. I took the positive that I 3D printed and put it in the base. And now I'm gonna set it right in the flask like that. So this is nice and ready. And here we have the plaster. I'm gonna add it to the water while whisking. And then I have some extra water here in case I need it to get to the right viscosity. So now I'm just going to mix this really well. And the goal is to make sure that there are no clumps and lumps in there. It's really smooth so that it can conform perfectly to our shape. And this, to me, looks a little thick. It's a little heavy. So I'm just going to add a little bit of water. It's very sensitive. So maybe that was even too much, but hopefully not. And the timer is ticking now, so we don't want to take too long doing this. Okay. So now we're going to take this container and put it into the vacuum unit. Just like that. And then on the front, we're going to set it, we're going to first turn it on and then set it over here. So it's pointing at investment table. You can see the pressure dropping. So it's pulling a vacuum. And then here, we'll see it start to bubble. We're going to do this, for maybe a minute. You can also bounce the table to help get the bubbles out. All right, so it's starting to fall. It was going up and now it's falling. So then it's important that you go to release vacuum first and then turn it off. And vacuum is going back to 0. And here's our degassed plaster, which we're gonna take and we're gonna pour it over our plug. And when we're pouring it, you wanna pour it down the side so that it fills up from the bottom and doesn't have bubbles in there. And now we're gonna degas this. So this goes back in here with the lid, back on top, turn this on, and set to investment table. So there are no big bubbles coming out, which is pretty good. You can see some. All right, so I think we've gotten most of the big ones, and now when we release it and then turn it off, all those bubbles go away. So now we want to let this cure for about 4 hours. So I'm going to take the lid off so that humidity can escape from the top, and now we can do some cleanup. So these bowls, obviously the table, we want to make sure to clean all the plaster up. Once this plaster hardens, it's much harder to clean up, so we're gonna dispose of this. So I found this container and I'm just gonna pour the excess plaster into there. It'll cure and we can just toss the whole thing out. And then I'm gonna wash this out in the slop sink. So then here at the slop sink, I'm just gonna wash off the implements before the plaster dries. So now that the plaster in the flask is cured, I'm just gonna clean off this edge because the gasket needs to sit right smoothly on there. We can take the tape off and take the rubber off the bottom. So here you can see the bottom of our 3D printed little plug. And now what we're gonna do is grab the burnout support from the drawer below. This guy, and go over to the kiln and burn out the PLA. So here we're going to select start. And then I've already put in PLA burnout. Ooh. And we're gonna click start. And we're not gonna add a delayed start. And then in the kiln, we're gonna put the base, and then we're gonna put the flask with this side down so the plastic can burn out. And it rests just like this so that air can flow underneath and the plastic can drip and burn out without just, getting on the bottom of the kiln or getting stuck in there. All right, so it's in there. We're gonna close the door. And then just to show you what the burnout cycle looks like, we're gonna click Schedule Summary. And here you can see that as fast as possible, it's gonna get to 300 degrees and sit there for 2 hours. That's just to warm it up and burn off any last water that's in there. Then it's gonna get to 700 degrees. And that's where we're gonna start to burn stuff out for 2 hours, and then 1350 for 2 hours. So that's gonna make sure that every last little bit is totally cooked out of there. And then it'll just cool back down. So that the total cycle is about 7 hours. So if your timing is good, when you're just as it is, cooling down from that 1350, you'll be able to melt your metal and go to the casting machine. But more likely, you'll have to reheat it back up to a hot temperature because you aren't going to be lucky enough to be here at exactly 7 hours later. Also, this is a burnout schedule for PLA. So if you're doing wax or something else, then you need to look up what the schedule is for burning out that material and program it in. Also, this is a badge tool, so you need to have already gotten the badge on this kiln. There's no checkout needed, it's just a video and a quiz, so you know how to use this and how to pay for the electricity that this machine uses. So we will come back in about 7 hours when that is all cooked out. So now that our flask is cooled, I took it out of the kiln so I can show you what it looks like. You can see some residue down there from the PLA that burnt out. And in here, there's nothing left. It was all cooked out. It's super white and clean in there, which is great. And what we're gonna do now is put it back in the kiln, and we're gonna heat it up to a temperature that's hot enough so that when we put the liquid metal inside of it, it helps to keep that metal nice and hot so that it can flow into all the nooks and crannies. If it was cold, then when that molten metal hit the plaster, it would solidify much more quickly. The metal that I'm going to use for this casting is aluminum, and aluminum melts at a relatively low temperature, around 1200 degrees Fahrenheit, but the gaskets in the casting machine can only handle up to about 800 degrees. So what I'm going to do is run what's called the flask prep schedule. So I click start and then scroll to flask prep. We're going to start that, and we don't need to delay it. And that is this schedule. It just gets it up to about 800 degrees Fahrenheit as fast as possible. So I'm going to put this back in here, and there's nothing more to burn out, so I don't really need to put it up on the stand. So we're going to put it in here, and then it'll give us an alert. It'll beep once it's up at 800 degrees Fahrenheit. And that's when we can start melting the metal and then do the casting. Another useful step is in your model, what you can do is assign a material to it. You can right click on the body and select physical material, and then assign a material to it. So I have assigned this to be aluminum. And then you can select the body and select properties, and it will tell you the total mass of the piece in aluminum. So here it's 0.519 ounces, and that is how much metal we know to melt down. Otherwise, we'd just be guessing and we might have too much or too little. So when we weigh out the aluminum we're melting, that's the number that we'll use, or maybe we'll round up a little bit to be safe. We're also going to fill this up with water from the hose next to the water jet. This is what we're gonna put our flask in once the casting is done to get rid of the plaster. So this is now full of water. Over here, we're gonna take this lid and move it away because we're gonna be using the right side now and don't need the lid. And we'll get these gaskets prepared. So there's the outer ring and then this inner ring, and then here, and our flask is gonna sit right on top of that. And we can get this ready by having it pointing to the casting chamber. So now is the stage where we're gonna start doing the casting. So as you can see, the kiln is up to 800 degrees. So the flask is up to temperature. It'll be nice and warm, actually really hot, to receive the molten metal. I am wearing a welding jacket and non-synthetic pants and leather shoes in case I were to spill some of the molten metal, welding gloves, and a face shield. This is not a welding face shield. It is shade 3, so it lets you see into the bright molten metal, and it also protects your face in case the metal were to splash. I grabbed these tongs, which live over with the other tongs, and then and these tongs are for picking up the crucible with the molten metal. And then these live in the top drawer under the casting machine and are for picking up the flask. A few other things I grabbed are some aluminum that we're gonna melt down, a scale from the drawers so that we can measure out how much aluminum we want. And then this is a graphite stirring rod from the middle drawer here so that we can mix the metal and help to remove any slag from the top. So here you can see we have graphite rods, some other skillets, and then down in here are the crucibles. So these are big casting crucibles that go in the kiln, but these are the ones we're using for the induction forge. So there are a few things. These white things are the sleeves that go around the graphite crucibles. So we'll grab one of these. And then the graphite crucibles, there's one for brass, bronze, and copper, one for silver, one for gold, one for ferrous things, and one for aluminum, which is what we're using. Another note, so there is flux available in the casting drawers, but the flux corrodes the graphite. It eats away at it and destroys it. So you don't want to use it for aluminum. You mostly want to use it for the things that have copper in it, and use just a sprinkle, and that helps to remove some of the slag so that you can pull it off at the end from the top. And then obviously before you put these things back in this wooden shelf, you should make sure to let them cool, or else they'll just catch this on fire. All right, so we'll take these out and we're gonna place them in here. So this is the crucible coil on the induction forge, which you obviously need to be badged on to use. And this is a shelf that folds up and down, and it has a refractory cement panel in it that can handle the incredibly high temperature that this will get to. When we are using this, we're gonna turn the water cooler on first, making sure that it's full of water, turn this guy on, and then the goal is to melt the metal, remove any slag off the top, and then we wanna keep it molten. We aren't trying to have it be boiling, bubbling, but we are trying to have it be molten so that we can put the flask into the vacuum machine and then pour this liquid metal into it. So when you are melting metal, it can release fumes either from stuff that is on the metal or from the metal itself. For example, when you're melting something like brass, it has zinc in it, and the zinc's boiling point is around the copper's melting point. So when you're melting brass, you are going to release some zinc fumes, and for that reason you need to make sure to have the fume extractor located right above this when you're melting the metal. So now we are going to turn on the fume extractor. Bring this over here. Turn on the water cooler and the kiln. We said that we wanted about a ½ ounce of metal. So that's 1.6 ounces, so that's more than enough. One other piece of preparation that I've done is there are Velcro straps here, and I've used them to hold these flaps open so that we can easily get from that area into the jewelry area while our hands are holding the metal, because we don't want to be pushing those super hot things through the plastic and melting them. So here we have the current set to high and we're on manual. So I'm going to push the pedal, and this is going to start heating up. And all the other old bits of aluminum that were in there already will just melt into the mix. You can see it's starting to glow a bit there. Alright, so now that it's mostly a liquid, I'm going to turn the current down a bit, because we're just trying to keep it a liquid, not get it any hotter. Alright, and now I'm going to switch this to auto mode, so that it's going to, and then stop and start. So now it is running on its own. Now we're going to transfer the flask over to the casting area so that we can get that ready. Aluminum takes a little while to cool down and solidify, but what you can do is just give it a little, jiggle and see that it's still molten, so it still needs time to cool down. So while the aluminum is cooling down, I'm just gonna turn this off. And then we're just gonna let this cool down over here, because you can see it's still glowing hot. So now that the aluminum seems to have cooled down, I'm just giving it a poke here, and it feels nice and firm, though it's still extremely hot. I'm gonna turn this, and we heard that vacuum release, so now we can turn it off. And we're gonna then use these tongs again to pick this up and put it into our bucket of water. And you'll see all the plaster just kind of dissolve and explode off of there. And then we'll have our part and we can see how it looks. You can see there's some plaster down at the bottom there that's settled out. Once this thing starts to get full of plaster, then you can pour off the water into the water jet, then pour the plaster into a trash bag and put it in the trash. Down it goes. All right, so it's cooled off mostly. I'm just gonna let let that keep cooling off. And here we have our lovely little robot. So now what you could do is, clean it off with a file or with a hose or putting it in the ultrasonic cleaner. But if you look closely, you can see even the lines from the 3D printer in it. So it's a really fine casting. It's a really good reproduction. There's still some plaster in the eyes and in the antennas and hands, but I'll put it in the ultrasonic cleaner for a bit and then that'll clean it out. And obviously you can cut off this sprue piece and recycle it, use that aluminum for your next casting. That's pretty good. So here in the ultrasonic cleaner, we can just drop this guy in, turn that on, and it'll help to buzz off some of the plaster that's left on there. But honestly, probably just the hose in the sink would do just as good of a job. But now you can see through the eye holes, and you can see that it's really a very good casting. The antenna and the ridges on the feet. That aluminum got into really every nook and cranny. All the corners are super sharp. So you can do some really fine details. Then in terms of cleanup in here, this is off. We'll turn the water cooler off and the air. Once the crucibles have cooled down, we can put them back in the drawer. The scale, as well as the flask holder, can go back to their drawer. These tongs can go back. And then while we're in this drawer, just as a note, the induction forge is a cool way of doing a large quantity of metal, but if you're just doing a little bit of silver or gold, you can just use these little cups. You can just, heat this little crucible up using a butane, propane, or oxyacetylene torch, melts it in, and then just pour your metal right into your casting. So the induction forge you only need to do if you're using a larger volume. This we can wash off to get the extra plaster off for the next person. And now for this, we can just rinse this out in the water and make sure it's nice and clean before putting it back in the drawer. So now that this is nice and clean, we can reunite it with its base and put it back in the drawer. So then this goes back in this bottom drawer. And then we can let the straps go here. This is now cooled down. Because these induction casting tools are used for things in addition to just the vacuum casting, these live out here and these tongs live over here. And then just as a note, these big tongs are used for these big crucibles down in here. And then as one last note, so here is the guy that we just made, but this is one that we made out of copper. That's a little different, didn't work quite as well. That was our first attempt. And you also want to fold this down when you're done just by squeezing the little handle on the bottom. And then after you've cleaned up this area to make sure everything is just as nice and clean as when you got here, you are good to go. So thanks for watching and enjoy casting.